In question 8f, okay, this is another question that we get unknown powers. Okay, unknown powers. So if you have looked at my solution explanation for question 8d, you would have be able to identify that this is a question type that we can solve by doing substitution. Okay, doing substitution. So alright, very quick condition to check is there's unknown powers, and the unknown powers exist in different terms in an equation like this. So in this equation we have three terms. 1, okay, 2 times 7 power q. 2, second term is 3, and the third term is negative 5 square root 7 to the power q. So we have three terms, and the unknown power exists in 2 of them. Alright, so we can aim to do a substitution here. But before we do a substitution, we got to figure out what is the unknown, okay, what to substitute. Alright, so we can do a little bit of law of indices, okay, with this square root here. So 3 minus 5 times 7, square root is a half, so we will get 7 to the power q over 2. Okay, so after this step, alright, you can see that this 7 to the power of q, okay, the power of this 7 to the power of q is actually double of 7 to the power of q and a half. Alright, so what we can do here now, under this condition, we do a substitution of x equals to 7 to the power of q and a half. So that after the substitution step, okay, we will have x squared here, okay, to the 2x squared, alright, and then we have 3 minus 5x. Okay, if you still can't see the point why it is x squared, okay, maybe I can rewrite out this step here. Okay, q is actually q and a half times 2. So we have this term of 7 to the power q and a half to the power 2. Okay, so in a way, if you are able to group the terms, okay, these two terms here, you can see that it actually resembles a quadratic equation. So we do a substitution for 7 to the power of q over 2, okay, to get our quadratic equation here. Okay, then we shift all the terms to one side. Alright, and this quadratic equation can be solved by factorizing. So 2x minus 1 times x plus 3 equals to 0. Okay, and after this step, we will have x equals to half, x equals to negative 3. Alright, and once we got these two values of x, okay, we got to check the validity of the solution. Alright, so by doing a substitution here, okay, substitute back the 7 to the power of q over 2 equals to half, and if we do a substitution, 7 to the power of q over 2 equals to negative 3, okay, this is actually not applicable. Okay, we have to reject this, because for a positive base, alright, q over 2, no matter q over 2 ends up being a positive or a negative number, you sub value of q in, you will get a overall value. So if q over 2, no matter if it is a positive or negative value, it is not going to change your positive base of 7 to a negative number. Okay, more detailed explanation I have given in exercise, this same exercise, question 8d, the solution video of question 8d. Alright, you can go and have a look. Okay, but a very quick property of power is that it doesn't change positive base to a negative number. So in this case, we reject the negative 3, and we continue to work with this 7 to the power q over 2 equals to half. So for this situation, alright, we can take log on both sides. Okay, take log on both sides, because if you want to solve by changing half to base 7, it is quite a tedious and probably impossible task. So we take log on both sides. Okay, on both sides. So for equation where you have unknown power and you can't change the base conveniently, this is when taking log on both sides will work. Alright, so log 7 cube over 2 equals to log half. Okay, take log on both sides, and then we bring down the power. Q over 2 times log 7 equals to log half. And we can do a division, log half over log 7, and Q is equals to 2 times log half over log 7. Okay, we multiply 2 across. So after this step, you can do your calculator. Okay, just punch into your calculator. You will get Q is equals to negative 0.71241. So if I round off to 3 significant figures, negative 0.712. Okay, so this Q value can actually fit into your equation. Alright, because on the left and the right side of your original equation there's a 7 to the power of Q. So if you are concerned as to what I have gone through previously, we reject a negative. Okay, this is clear cut. You have a 7 to the power Q over 2 equals to 3, but in this equation here, on both sides you will have this same. So it is likely that on the left hand side here you can end up with a positive value. So 7 power Q gives you a positive value. Alright, so this is our answer for 8F.